For the past decade, the traditional automotive establishment has been running a massive psychological operation on car enthusiasts worldwide. They told us that the solid-state battery was a distant mirage, a theoretical holy grail of engineering so volatile and complex that we wouldn't see it on public roads until well into the 2030s. Legacy brands use this timeline as a convenient shield, an excuse to keep overcharging us millions of dollars for heavy, thermal-compromised lithium-ion packs and over-engineered combustion engines that belong in a museum. But today, the timeline has been completely shattered. The GAC Hyper SSR is no longer just a shiny carbon fiber show car sitting under spinning lights at an international auto expo. The disruptive reality shaking the global industry right now is that the world's first mass-produced solid-state powered hypercar has officially transitioned to the active assembly line. In today's forensic breakdown, we are going to explore exactly how GAC achieved this impossible commercial scale. We will dive deep into the brutal thermal warfare of their new solid-state chemistry and analyze why their giga-scale reality currently holds the upper hand against domestic titans like Chery. We are also going to dissect how this solid-state heart perfectly integrates with the SSR's true 900-volt architecture, its over-engineered T800 aerospace carbon chassis, and its aviation-derived tires to create an uninterrupted force of nature. By the end of this video, you will understand exactly why the reign of the European hypercar cartel is officially over. Buckle up, because the future did not wait for the legacy brands to catch up. It is being stamped out right now, panel by panel, in Guangzhou. We have to understand that GAC isn't developing this technology in a vacuum. There is a brutal, high-stakes arms race happening inside China right now that the Western media is barely covering. Just weeks ago, Chery dropped a massive bomb on the industry, unveiling their own solid-state technology targeting a staggering 1,500 kilometers of range, aiming to pilot the tech in their Exceed ES8 model next year. Chery is a titan, and their solid-state roadmap is aggressive, boasting capabilities like a 5-minute charge for 500 kilometers of range. But here is why GAC holds the absolute upper hand in the hypercar space and why the SSR is ready now. It all comes down to the brutal reality of manufacturing scale. GAC's backed entity, Greater Bay Technology, isn't just making promises for next year. They have already successfully rolled all solid-state A-sample cells off their production line in Guangzhou. They have already achieved the critical leap from pilot-scale laboratory mixing to automotive-grade mass manufacturing. GAC has the structural muscle, the gigafactory ecosystem, and a proprietary dry anode manufacturing process that eliminates the slow, expensive wet processing steps of traditional lithium-ion. They aren't just designing a battery. They are targeting GWW-scale mass production by the end of 2026. While Chery is aiming for long-range commuter endurance, GAC has successfully weaponized solid-state technology for the ultimate high-discharge, hyper-performance environment. They have the factory infrastructure to outproduce and outscale almost any competitor on Earth. We have already broken down the basic differences between traditional NCM and LFP chemistries in the past. So we're going to skip the textbook academic lectures and talk about pure thermal warfare. In standard electric supercars, energy has to travel through a volatile, liquid electrolyte medium. The moment you demand over 1,200 horsepower from that chemical pack, resistance builds up and the liquid medium begins to cook. To prevent catastrophic thermal runaway, these cars are forced to carry massive cooling systems, heavy radiators, complex liquid glycol loops, and high-pressure pumps. All of that weight acts as a parasitic drain on efficiency. Even worse, after just 2 or 3 extreme launches, the onboard software panics, detects the thermal spike, and chokes the power, throwing the car into an embarrassing limp mode to protect the hardware. The integration of GAC's true solid-state battery pack into the production line Hyper SSR completely eliminates this fundamental engineering bottleneck. By replacing the unstable liquid medium with a dense, proprietary deep eutectic composite solid electrolyte, GAC has fundamentally rewritten the laws of EV thermodynamics. The threat of dendritic short circuits is completely neutralized. These new cells have literally passed needle penetration and crushing tests without fire or smoke. The pack's thermal threshold is elevated to staggering heights, capable of withstanding internal temperatures that would incinerate a traditional lithium pack. The Hyper SSR has successfully purged dozens of pounds of legacy liquid cooling hardware. The car is not just lighter and exponentially more energy dense, it is thermally bulletproof. You can now dump all 1,225 horsepower into the pavement over and over again, lap after lap, without the central computer ever needing to dial back the performance. Solid state has transformed transient peak power into an unyielding, continuous baseline. This is where forensic engineering reveals exactly how lethal the production spec Hyper SSR has become on a global scale. If you look back at the core electrical architecture of this machine, it was engineered around a true 900-volt system working in tandem with molded silicon carbide inverters. Remember that we discussed this heavily in our previous deep dives. These advanced inverters were already operating at an astonishing 99.8% energy efficiency, translating raw current into motion with almost zero heat loss. Now, imagine plugging that ultra-high voltage, near superconducting powertrain directly into a solid-state battery pack capable of instantaneous or massive discharge rates. We are talking about stable 2C to 3C fast discharging without thermal panic. It is the most devastating marriage of electrical engineering the automotive world has ever seen, because the solid matrix can handle immense current transfers without overheating. It completely eliminates the phenomenon known as voltage sag. In a standard high-performance EV, as the battery depletes or gets stressed, the voltage drops, and the car loses its punch. Not here. The Hyper SSR can now sustain its mind-numbing 12,000 Newton-meters of wheel torque from 100% charge all the way down to the final single digit. That 0 to 60 mph sprint in 1.9 seconds is no longer a localized marketing metric achieved once under perfect track conditions. It is now a repeatable, mechanical reflex that the car can execute relentlessly, punishing any $5 million legacy hypercar that dares to pull up alongside it. When you unleash that level of unyielding, continuous gravitational force onto a production vehicle, a fundamental engineering question arises. Can the structural frame actually survive the abuse? This is exactly where the pieces of the puzzle we analyzed earlier snap perfectly into place. GAC did not manufacture the entire body and monocoque out of aerospace-grade T800 carbon fiber just for aesthetic premium value or showroom appeal. They were playing the long game. They knew the solid-state powertrain was coming. Under the sustained longitudinal and lateral G-forces that this new high-density battery pack can maintain, a traditional aluminum or mixed alloy chassis from a standard European sports car would literally begin to flex, fatigue, and deform under the sheer structural stress over time. The Hyper SSR's frame, however, was industrialized using automated, high-pressure autoclaves, achieving an absolute torsional rigidity rating of over 50,000 Newton-meters per degree. The skeleton of this car was engineered from its very first CAD drawing to act as an unyielding anvil for solid-state forces. While the old guard in Europe treats carbon fiber as a slow, artisanal craft to justify their artificial markups, GAC industrialized stealth fighter-grade materials at scale, because they knew they needed an unbreakable foundation to contain the most advanced production battery pack on Earth. If the chemical heart of the vehicle is now capable of delivering endless, violent propulsion, the final point of contact with the asphalt must be an absolute mechanical anomaly. This is why the production SSR rides on custom rubber derived directly from the aviation sector. We are talking about aircraft landing gear technology, specifically compounded to withstand the violent frictional heat and instant load spikes of a 200-ton commercial jet hitting the tarmac at nearly 200 miles per hour. With a solid-state battery deploying torque to all four wheels without a shred of hesitation, any standard track day consumer tire would disintegrate or delaminate within minutes of sustained hot laps. These aviation-derived tires ensure that every single kilowatt of solid-state energy is translated into pure, forward vectoring force. Furthermore, because the solid-state pack operates with complete thermal stability, the Skyforce active aerodynamic system has undergone a massive paradigm shift. The active front intake shutters no longer need to constantly divert massive volumes of high-velocity oxygen to cool down boiling battery cells. Instead, that entire aerodynamic payload can now be clean-channeled directly underneath the sealed carbon fiber flat floor, rushing toward the aggressive rear diffuser. The venturi effect becomes exponential. The Hyper SSR is literally vacuum sealed to the asphalt, generating immense downforce in the high-speed corners, ensuring that the 1200 horsepower is used to conquer aerodynamic drag rather than fighting for survival against the wind. What we are witnessing with the GAC Hyper SSR rolling off the assembly line with solid-state technology is not just an incremental technological update. This is a full-scale geopolitical and financial execution of an antiquated automotive business model. For over 70 years, an elite cartel of European manufacturers has dictated the terms of high performance. They hid behind the romanticized notions of hand-built exclusivity and mechanical complexity to charge astronomical sums for vehicles that require $50,000 oil changes and fragile dual-clutch rebuilds every few thousand miles. The solid-state Hyper SSR is the financial guillotine coming down on that entire ecosystem. It has completely democratized the impossible. By scaling solid-state chemistry into an active, globally validated production car out of a giga-scale factory, GAC has proven that ultimate speed and absolute thermal reliability are questions of advanced manufacturing competence, not aristocratic heritage. If you are still paying millions of dollars for a legacy badge on a steering wheel, you are no longer purchasing cutting-edge performance. You are merely financing the historical inertia of a dying era. The reign of liquid electrolyte compromise and million-dollar exclusivity taxes is officially over. The new era of speed is solid. It is built from automated aerospace carbon. It is rolling off the assembly line right now, and it doesn't cost the GDP of a small nation. The future has arrived with unmitigated force, and it is written in silicon carbide.